Precalculus students, these are your 5.2 notes. Today we're going to look at verifying trig identities. It's a really interesting topic. It doesn't have a ton of real life application, but it's kind of like solving a puzzle. It's fun. It sometimes takes patience, but you learn from it. And that's what we're going to do today. First, some guidelines. And these guidelines apply, I wouldn't call these steps to solving, but I would look at them as just things you can do. Now, the first one is something you have to do on all of them, and that's work with only one side. So pick the more complex side. It's generally simpler to take something complex and make it simple than it is to work the opposite direction. The next few steps are just ideas. You can try factoring, you can add fractions, you can square binomials, simplify denominators. You can do your fundamental identities like your Pythagorean identities, also changing things into sines and cosines, your cofunctions. But in the end, the point is this: no matter what, you have to keep trying. You can't give up on these. It's very possible that on a problem or two, you'll take a bad approach and you'll just come back and fix it. And that's kind of the process here. So let's jump right into some of these problems. So number one, sine squared x plus cosine squared x over cosine squared x secant squared x. First thing I notice is right here, sine squared plus cosine squared, that's 1. I'm going to make that simpler. And by the way, I didn't even mention this, but when you look at this equation, we're trying to make one side look like the other. Well, the left side is without question the more complex side. That's the side I'm going to work with. Now, in the denominator, I know that a secant is the same as saying 1 over cosine squared x. And we know cosine squared times 1 over cosine squared is just 1, and 1 is equal to 1. Pretty simple stuff. All right, let's try another one. Secant squared theta minus 1 over secant squared theta equals sine squared theta. Now I have to tell you, when I see this secant squared theta minus 1 in the numerator, I'm tempted to use the Pythagorean identity and change that to a tangent squared. I'm actually going to do, and that'll work by the way, but I'm actually going to do it a little bit different way this time. I'm going to split apart the fraction. So I'm going to say secant squared theta over secant squared theta minus 1 over secant squared theta equals, and again we're just going to work with this left side. Obviously it's the more complex of the two, and then let's start simplifying. Secant squared over secant squared, that's 1. 1 over secant squared is cosine squared theta. Now I'm going to use that Pythagorean identity because we know 1 minus cosine squared is sine squared theta. Okay, a couple things to point out as you do these. There's not an answer, there's a process. Okay, this is the Joel Embiid issue here, all right? There's not an answer, it's the process. And the process is important. You have to show every step. You have to work on only one side. You'll notice what I do is most of the time I just don't even rewrite the other side. You see here I just put equals and left it blank. That's my reminder. I'm not changing that side. I did the same thing here. I'll keep doing that. You only work on one. Pick your side and roll with it. It doesn't matter if it's left or right. Pick the more complex side. Again, you can't just jump to the answer and say sine squared equals sine squared. Done. Move to the next problem. That's worth 0 points out of however many it's worth. All right, let's keep on going. In all the problems today, one thing we'll see is there's frequently, if not always, more than one good option. Sometimes though there's an option that kind of sticks out as being the one that makes the most sense. So when I look at number 3, I say, okay, first of all I'm going to work on the left side. Second thing I see is I need a common denominator. So that means my first term needs to be multiplied by 1 plus sine of x. My second term needs to be multiplied by 1 minus sine of x. And when I say 1 plus sine of x, I really mean 1 plus sine of x over 1 plus sine of x. And same thing with the minus. It's both numerator and denominator, because I need this common denominator. And it'll look something like that. Now one thing we'll do is we'll take a look later. We may say, hey, I need to leave this in factored form, or I might need to multiply those. We'll look and see. But one thing I noticed right away, numerator signs are gone. So all that I'm left with in the numerator is a 2. I'm not going to cancel a 1 minus sine of x or a 1 plus sine of x. So I think it'd be smart to go ahead and multiply those. So I'm taking that common denominator and multiplying it. So I got 1 minus sine squared x. Now, I think most of you hopefully know this, that 1 minus sine squared x is exactly the same as cosine squared x. And hey, cosine, that's the reciprocal of the secant function. And if you look back, I've kind of moved down a lot, but I can see that it was 2 secant squared x on the right side, and I just made the left side look exactly the same. So we finished that one. Again, the goal is to make the left and the right look exactly the same. All right, number 4. Okay, again, file this under, there are many ways to do this. I think most of those ways are going to involve using the left-hand side though. Now, you could go ahead and multiply everything out here. That would be acceptable, but I think I'm going to do something else. I know 1 plus tangent squared is secant squared. So I got secant squared theta right there. I also know cosine squared theta minus 1. It's almost like 1 minus cosine squared. It's the opposite of that. So really what we have there is negative sine squared theta. Now there are a few ways you can get to that, and if you want to do a different approach, that's fine. Just make sure you can get there. All right, let's change secant squared into 1 over cosine squared. That's usually a pretty good idea. And then we'll have a negative sine squared over here. If you want to, you can mark that that's over 1. And we'll have negative sine squared theta divided by cosine squared theta. And hey, sine squared over cosine squared, that's negative tangent squared theta, and that's exactly what the right hand side looked like. So we have completed problem 4. Okay, number 5, we have a bit of a decision to make. I think this one's a little tricky because there's not much difference in complexity on the two sides. So I have the advantage of some experience, not just necessarily with this specific problem, but in general. My experience has been it's easier to change a fraction into not a fraction than it is to take something that's not a fraction and change it into something that is. So I'm actually going to work with the right hand side. Now, here's another thing I know. 1 minus sine of theta, let's use a conjugate. So I'm going to multiply both numerator and denominator by 1 plus sine of theta. Now remember, I'm not changing the value of anything here. I'm just simply rewriting it. I'm multiplying it by 1. And I'm going to go ahead and distribute this one. So I'm going to have cosine theta plus cosine theta sine theta over, well, 1 minus sine of theta times 1 plus sine of theta. That's 1 minus sine squared theta. I think we saw that one already. Another thing we saw is that we know 1 minus sine squared theta is cosine squared theta. We've seen that a few times. And when I look at the numerator here, the thing that sticks out to me is that maybe I shouldn't have distributed that cosine. So I'm going to go back to that format right there. See, that's one of those moments of like, I thought maybe distributing it was a good idea, but now that I look at it, I'm saying, hey, why not just cancel out these cosines? That seems to be an even better idea. So good idea trumped by great idea right there. All right, so 1 over cosine theta minus sine of theta over cosine theta. Again, all I'm doing is splitting the fraction into 2 parts. And this is lovely because the reciprocal of the cosine, as you know, is the secant. And sine over cosine of theta, that's tangent of theta. And I have a little issue here, don't I? Do you see the issue? I do. I have a sine issue right there, and right there, and right there. I've thought about going back and fixing that on my video and just cleaning it up. It would be easy for me to do that, just rewind and kind of clean up my mistake. But here's the beauty of it. You may make a mistake like that yourself. Probably not. Somebody will. And if you make a mistake like that, you'll realize, hey, something's not right here. Why does this one say plus, this one says minus? And that drew my attention. I'm like, okay, so I got to go up and figure out where I messed up. And oh man, that's a silly mistake. Why did I do that? But the good news is it allowed me to fix it. And so now I have a cleaned up problem. All right, number 6. Again, you got to pick side. To me, it's pretty clear that the right side is the more complex. And what I see is I have tangent squared here and I have tangent squared here. So I'm going to do some factoring, and I'm going to factor out that tangent squared and make it tangent of squared x times secant squared x minus 1. All right, I'm going to leave the tangent squared alone out front here, but we're going to use that Pythagorean identity. We have one that says 1 plus tangent squared equals secant squared. We could rewrite that as tangent squared equals secant squared theta minus 1. So this is actually just another tangent squared. And I mean, we've talked about this before. When you have tangent squared times tangent squared, or any variable squared times any variable squared, you just add the exponents. And that's exactly what I'm going to do here. And I'm done with number 6. Number 7, this one looks a little scary perhaps, but you kind of have to take a moment, step back and look at it. And when I'm looking at it, I'm seeing the right hand side. I can work with what's inside these parentheses, and here's how. I'm going to actually move the sign of x out to the front. It doesn't matter if it's just multiplication, so the order's not important here. But what I'm going to do is factor out a cosine to the 4th x. So I got 4 of them here, 6 of them here. Let's get rid of 4 of them. And then all of a sudden, this problem just became a lot less intimidating, because we've seen this many times. We know that 1 minus cosine squared is sine squared. And if you have sine of, oh, I left my variable out there, my angle, sine of x times sine squared x, that's sine cubed x times cosine to the 4th x. And that, not surprisingly, is exactly what the left side of this equation already said. So I know I've got that one. We're on a roll. Okay, number 8 actually looks to me like almost an identical problem to number 7. Different trig functions, but really the same concept. Right hand side, if you look inside the grouping, you see how we have a cotangent here and 3 cotangent here. So let's go ahead and factor out one of those cotangent of x's. That leaves me with 1 plus cotangent squared x. And we have another Pythagorean identity. I don't think we've used this one yet on these notes, but 1 plus cotangent squared theta equals cosecant squared theta. So 1 plus cotangent squared x is cosecant squared x. And cosecant squared times cosecant squared is cosecant to the 4th times cotangent. And again, the left and right look exactly the same, so we know we are finished. Again, I've said this once, I'm just going to repeat it. Just putting cosecant to the 4th x cotangent of x equals itself with a check mark is not enough. You've got to show these steps in between. You got to stick with the properties and rules that we know. Hey, I think we're down to our last problem now. All right, so on our last one, number 9, we run into a little bit different situation. This problem looks obviously very different from the others. Good news is it's not real complex. We're just using the cofunction idea, where we know that, for instance, that the cosine of pi over 2 minus x is equal to the sine of x. So it's just saying if you switch from one acute angle to the other in a right triangle, then you just switch from the cosine to the sine, or sine to the cosine, whichever order that happens to be. So here's what I'm going to think about this. 26 degrees, that's the same as saying like 90 degrees minus 64 degrees, right? And so the cosine squared of 90 minus 64 is exactly the same as the sine squared of, we're using this cofunction property here, 64 degrees plus cosine squared 64 degrees. Folks, we have a Pythagorean identity. Sine squared theta plus cosine squared theta, that always equals 1. So if we get this situation, see if you can adjust it to make the angles the same by switching functions. Again, kind of an out there problem, but one that you'll see, so I wanted you to get a little bit of a view of it. Hey, that's what we have today. Now, the real deal, and you got to know this up front, is just watching this video isn't going to make you know what's going on. You are going to have to practice. Here's another thing. You're going to mess up, and you're going to make a lot of mistakes, and then you're going to fix them, and you're going to try again, and you might make another mistake and then fix that mistake, and you may have to repeat that process a few times. But folks, Pythagorean identities, you can all handle them. It's very much manageable. You just need to learn some of the identities we've been studying this chapter and in the previous chapter. So I hope you guys have a fabulous day, and we'll see you soon.